Okay, what's up, guys? Welcome to today's show. Today we are gonna talk a little bit about databases. So, what I want to do is I want to create my own database. So, what are we gonna talk about today? We're gonna talk about the actual design of these data structures. So, when you design a database, you need to decide how to store the data inside of the memory. I'm not talking about disk space right now. I'm talking about how to store everything in memory. So we have a couple of options, and I have decided on using something called a binary tree, or rather it's my own interpretation or my own design of which is based on a binary tree. So a regular binary tree looks something like this. We have a couple of these so-called nodes, and then we have let's say we have another node right here, and then we have a couple of leaves. So it's just like nodes and leaves on a tree, and each of these nodes and leaves have different kinds of connectors. So as you see, the nodes, they have two connectors downstream, which means that every one of these nodes can connect to two different data structures downwards. So this node connects to this and downwards to two of these leaves, while this node connects to another node. So it's one additional level. And then we can have, that's not right. And then we can have a leaf right here, and perhaps two leaves connecting to this one. So what are the difference between leaves and nodes? Well, these nodes are the hubs or connectors. They basically make up the structure of the tree, while and they don't contain any actual value, no actual data. These leaves, however, they each contain one single element. And these elements could be like one int or one char, but it can also be one structure and perhaps a char pointer with a string inside. And that is what I intend to do. This is the standard way of doing a binary tree, but I'm gonna modify it a little bit. So if we go back to the beginning, and let me select this blue color I had before. So let's start in the middle. Here we will have one node, which is the root node. That's the first node, and it will have the path /. Then let's say we have 2 additional nodes on each level like this. So the root has a slash as a path, and then this layer or level might have the path slash users. And then down here, this might be slash user slash login or something like that. So these nodes, let me just put the word here, nodes, always go to the left, downwards to the left, right? Then we have a line going to the right from each of these nodes. And here are all the leaves connected. So in the original design, there was only 1 or perhaps 2 leaves per node. But in this case, we may have a whole lot of these leaves. And the leaves, remember, they contain the values. So this is a little bit more suitable for a database, because with this design I may use these paths, these nodes, as a file system almost. So this becomes like folders. So this is the user folder, and this is the slash user slash login or something. So the nodes are the folders containing all of these leaves. But how do we define a data structure of this kind in the C language? Well, as you might have guessed, we either store, at each level we either store 1 out of 2 data structures, either a leaf or a node. So let's create a union. And perhaps you don't know what a union is, but I will explain that shortly. Let's call this U tree. And what does this union contain? Well, as I mentioned, 1 out of 2 things. Either it's a node, and that's a struct s node, let's call it n, or it's a struct s leaf l. So this basically looks like a struct, right? We have this name, and we have different variables inside. However, what's different is if this were a struct, then this would take up a bit of the unit of this structure's memory, and this would take up some other part of this structure's memory. So basically we could both define the n and the l at the same time. But in a union, we do only have one of these at the same time. So we either define the n or the l. So this union either consists of a node or a leaf, which makes it perfectly suitable for creating a binary tree with, right? Okay, so let me try to zoom in down here without turning the page. There we go. Okay, so what is a node? A node is as I mentioned before, a struct S node. So it's a structure. What does it contain? Well, as you might remember, I can draw a little basic picture. And we have a link up and we have two links right here. No, not right here, like that. Like this is better. So basically, here is the uplink to the node below, above it. This is a downlink to the node below it. And this is the arm to the right, where we connect all the leaves. So how do we define that? Well, if we begin with this upper one, let's just do struct, and we know it's a node because it connects to another node. So S node, and if we make this quite similar to a linked list. So we use a pointer and let's call it up. And then we have struct S node star, and we have the left. And finally, we have a struct S leaf and a pointer to the right. And in addition to this, I do also want to have a tag. So let's do tag. And that's just so we can define what kind of structure this is. So we can differentiate on the data level between a leaf and a node. I'm not 100% sure that it will be necessary to use this, but let's add it now and remove it in case we choose not to use it. But we do also need a couple of other things. So if I scroll a little bit here, let's say we continue this structure. I want to have something like a path. So we can give this a path like /users or similar, like we did in the example. So let's just do this as I'm calling it char now. I will probably call it int8 later on. But let's do char and what should we call it? Folder perhaps, or just path. And then we give it a size, perhaps 255 or something like that. We can decide later. But that would be a regular string containing the path to this node, so we can access it on the user level. The thing is, when the user connects to the database with, let's say it connects just to the TCP port, then it should be able to do something like create and the name of a folder like this. And then it should create one of these structures, link it correctly, and put these users inside of this path. Okay? So this is quite simple. A node just links everything together. Let me zoom in a little bit here. So, what's next? Well, we need to define the leaf. So we have a struct s leaf. And what does it contain? Well, we do have a link to the left. Right. I'm not 100% sure that I will use this either. Perhaps I will just point in one direction with the leaves. But for now, let's do this. So this will be a struct s tree because it can be both a leaf and a node. And a pointer, and this will go to the left. So this is the leaf's link. What does it contain then? Well, as I mentioned, every single one of these leaves will contain one element, and one element being a string. And in order to make this effective, I intend to allocate these strings on the heap. So the only thing we will store is a pointer, which we will allocate later on. So char, and this is the well, let's do like this instead. Let's wait a little bit with this value, because first we have the key, because this database will be, each leaf will have a key that distinguishes it. So char key, and this will be a string like this. So a key, and then we have the value as a pointer, which will be allocated on the heap. And we will also need to have a count. So int count, because we need to know how many characters this value will be. The key will be a standard null terminated string allocated like this, but the value should be able to be both bigger and smaller than 255 dynamically. So we'll allocate it on a heap. And then we have the count, and just like before, we will also have a tag. So if I zoom out, we should be able to see all this together. we have a union of nodes and leaves, which we call a tree. We have this part, which is a node containing of the uplink, the left link being the connector to the next level, the subfolder basically. And then we have the right one, which is the first of the leaves in this row. And then we have a path like /users, and we will also have a tag. So the tag will be something like an int value, where 1 may be a node, or 2 will be a leaf, and so on. Simple stuff. And finally we have this leaf, which contains the left connector, perhaps. It contains a key, and it contains a pointer to a value and a count of the bytes, as well as a tag. And using these two structures, or three, perhaps we can call them, we will be able to create this tree-like structure. Let me go back to this pen, where we have the nodes, one for each level, and we have all of these leaves connecting with an arm like this. So if we were to describe this in computer networking terms, perhaps these nodes would be a router connected like this, and then they have a switch to the right connecting to a lot of different end user computers or something like that. So this is my take on a kind of binary tree with a little bit added to those. So in the next video, what we'll do is we will begin coding on this data structure. We will have a method for searching effectively, and we will create all different types of nodes and leaves and stuff like that. Storing values, finding those values fast, and we will also be coding the actual networking database program. And this is basically all for today. If you like this video and this kind of content, you will be very interested, I think, in this series, at least when we start coding, right? Which is the next episode in a couple of days or so. So thanks for watching, thanks for liking, thanks for subscribing, and I'll see you real soon. Thanks for watching, and thanks for today.